So now I will derive, find the derivative of x position with respect to time. It's as easy as can be, just have to take dx dt. I will derive, hey, hey.
Now we're going to talk about points of inflection. I'm going to draw the graph of f double prime. And points of inflection are where the graph of the second derivative of f changes from concave up to concave down. So will you draw the points of inflection?
Okay.
Good job.
Thank you.
Today we're going to look at the relationships of the graphs of derivatives. Here is the function f. Now I'm going to draw f prime.
Why is f prime increasing?
Because the graph of f is concave up. Now I'm going to draw the second derivative of f.
Why is f double prime positive?
Because f is concave up and f prime is increasing. Today we're going to talk about the critical numbers. And a critical number is where the x value of the derivative of a function equals 0. And I'm going to show you how to find the critical numbers of a function. So right now we have the function, and it equals x cubed minus 3x squared. And first you take the derivative, which equals 3x squared minus 6x. And then you can simplify that down to 3x times x minus 2. And then you find the zeros, which x would equal 0 and 2. And those would be your critical numbers.
Another example of critical numbers is this function, which is x squared plus 6x plus 10. And to find the critical numbers, first you have to take the first derivative. And the first derivative is 2x plus 6. Then you find the zeros of the first derivative, so you can take out a 2. Which gives you 2 times x plus 3. And the zeros of that is x equals negative 3. So that's your critical number.
Now we're going to talk about the derivatives test, and this is for the first derivative. So we're going to use the equation f of x equals 5x to the 4th. When we take the derivative, you get 20x cubed. And then you want to find your zeros for the derivative. So your zeros for this equation would be x equals 0. And then you're going to make a sign chart to find out where it's positive and negative. So you're going to pick one upper and one lower. So we're going to do -1 and 1 as our 2 points. Then we're going to plug 1 back into our derivative and see what we get. So 20 times 1 cubed equals 20. So that's positive. Then we're going to plug in -1. cubed, that will give us negative 20. So it's negative. So on the sign chart where it's negative, that is where f of x is decreasing. So f of x is decreasing at x is less than 0. F of x is increasing at x is greater than 0. Okay? Now, we're going to talk about maximum and minimum. So, where if on the sign chart it goes from negative to positive, that is a minimum. So, f of x has a relative at x equals 0. And say this went from positive to negative, that would be a maximum. That's all for first derivatives. Alright, now we're going to talk about the second derivative test, which will cover point of inflection and concave up and down. So we're going to take that first equation, 5x to the fourth, and then we're going to take the derivative, which is 20x cubed, and then we're going to take the second derivative, which is 60x squared. Okay? Then we're going to find our zeros again, which will be 0. And we're going to plug them into our sign chart, and we're going to take upper and lower, just like we did in the first one. Alright? And then we're going to plug 1 back into our derivative. Alright, when we plug 1 in, we get 60, which is positive. And we're going to plug in negative 1, which is also positive. So, on our second derivative sign chart, where the graph is positive, it will be concave up. So for this equation, for 5x to the fourth, it will always be concave up. And say this came out negative, then you would say x is greater than 0 is concave down. And if that happens, then 0 would become a point of inflection because it goes from concave up to concave down, or vice versa. And that's all for a second derivative.
Here I drew the graph of f, and we are going to graph f prime and find the relative extrema. Do you know how to graph f prime?
F prime is positive when f is increasing and negative when f is decreasing.
Would you like to draw it? And that's f prime. And to find the extrema, do you know how to find the extrema of?
The extrema is where it changes from increasing, or where f changes from increasing to decreasing, or decreasing to increasing.
Okay. Would you like the graph, or I'll mark them on the graph? Okay, now draw the extrema points of the graph of f prime. Good job.